Hey everyone, welcome to today's Explainer. If you're a facility manager, an infrastructure engineer, or honestly just anyone involved in keeping a modern data center online and thriving, you are in exactly the right place. We spend a ton of time obsessing over cooling systems, redundancy, and network architecture, right? But today, we're literally looking right under our feet. We're going to explore the absolute foundation of data center safety, polished, densified ESD concrete floors. Let's get right to it.
So ask yourself, what is the literal foundation of data center safety? It's so easy to just think of the floor as this passive surface, just a concrete slab holding up the heavy racks, right? Well, actually, scratch that. In a modern, high-grade facility, the floor is an active, deeply integrated piece of safety technology. It's literally the protective barrier standing between millions of dollars of sensitive electronics and catastrophic electrical events. It is doing real, measurable work for you every single second of the day.
To understand exactly how it pulls that off, we're going to walk through 4 key areas today: the data center standard, step-by-step installation, essential upkeep and maintenance, and finally, what to strictly avoid.
Okay, let's dive straight into Section 1, the data center standard. Let's figure out what separates this highly specialized surface from your run-of-the-mill concrete.
So, polished densified ESD concrete is a high-grade concrete slab treated with a silicate-based densifier. And this is crucial. It meets the rigorous ASTM F150 standard. The main job of this floor is to stop dangerous static levels from building up and to block those sudden stray current spikes that can instantly fry your electronics. How does it actually do this? It's pretty cool. The silicate treatment chemically reacts to harden and tighten the cement matrix itself. This reaction cuts weight out on the concrete's natural porosity, entirely stops it from dusting, and significantly boosts its abrasion resistance. What you get is a surface that's super easy to clean, but still rated to carry massive, heavy rack loads without any deformation whatsoever.
So why is this becoming the absolute go-to standard? First off, you're getting high load-bearing capacity with zero deformation under the sheer weight of your data racks. But here's the absolute game changer. The ESD densifier coating isn't just some topical layer sitting on top of the concrete. It integrates directly into the slab itself. Because it becomes part of the actual concrete matrix, your risk of delamination over time is incredibly low. It literally can't peel up. Combine that with the fact that it's super low maintenance, really only needing occasional resealing, and absolutely does not generate concrete dust. Yeah, you've basically got the perfect environment for servers.
Moving right along to Section 2, step-by-step installation. Let's look at how this foundation is built.
Building this floor doesn't just happen overnight. It's a deliberate, 6-stage process on the existing structural slab, and every single stage is strictly checked before the next one starts. Step 1 is the site assessment. This is where the existing slab gets meticulously inspected for moisture, cracks, spalling, and flatness to dictate the repair plan. Next up, Step 2 is grinding. They use coarse diamond tooling to level things out and open up the concrete's pores. Now, Step 3. Pay attention here because this is absolutely essential: crack and joint repair. Every single crack, pinhole, and control joint has to be filled so the finished surface is perfectly monolithic. If you leave gaps behind, they will physically break the static dissipative path. It has to be seamless. Step 4 is densifying, where that silicate-based densifier is applied to hit the ASTM F150 rating. Step 5 is honing and polishing with progressively finer grit to get the specified sheen, totally without adding any topical coatings. And finally, Step 6, resistance testing and sign-off. The floor gets rigorously tested for surface and point-to-point resistance, and everything is fully documented before handover.
All right, Section 3, Essential Upkeep and Maintenance. Here is how you protect that asset.
Let's break down your operational playbook. Your daily tasks are all about light, gentle care. You're going to want to dry mop with microfiber just to grab the dust, and spot clean with a damp microfiber cloth and a suitable agent. But here's a critical daily habit. You must check for any new cracks and report them to your Building Management System, or BMS, immediately. Now, contrast that with your weekly tasks where you kind of step things up. You'll do a thorough vacuum using a suitable machine and execute a full damp mop with microfiber and a suitable cleaning agent. Consistency and gentle cleaning, that is the real secret to longevity here.
To make sure you don't accidentally do more harm than good, there are a few key principles you have to follow. You definitely want to avoid acidic or high alkaline products. Never, ever apply waxes, acrylics, or anything that leaves a film. Skip the harsh solvents, and always stick to soft pads. But honestly, what's really fascinating here is the environmental factor. You have to maintain relative humidity between 45 and 55%.
The air in the room directly impacts the floor's performance, because very dry air actively increases static generation. So managing the floor literally means managing the room's atmosphere too.
Which brings us to Section 4, what to strictly avoid, the absolute danger zone.
We are entering the danger zone, and these rules are completely non-negotiable. First, absolutely no wax, polish, or topical sealers. And I want to be super clear on this. Even if a product is heavily marketed for use on concrete, do not use it. They create insulating layers that literally block the floor's conductive network. Second, no oil-treated dust mops. The oils mess with conductivity and leave behind this insulating contamination. Third, no aggressive scrubbing pads, brushes, or heavy drag loads. They can scratch or gouge the surface and, you guessed it, break the static path. And finally, no highly alkaline, acidic, or solvent-rich products, and definitely no generic heavy-duty degreasers. Those will etch the surface and completely ruin the conductive network you just paid to install.
Because getting all of this right is incredibly detail-oriented, bringing in the experts is usually your best bet. As our source materials highlight, CTS builds and maintains these ESD-rated data center floors end-to-end. If you're looking to set up a highly customized floor care program for your specific facility, you can easily reach out to them. Their WhatsApp is +91 963 9535 455, or you can just shoot them an email at connect@colotechexpertsolutions.com to get that conversation started.
So, as we wrap up today's explainer, I want to leave you with one final provocative question to really think about. Is your current facility's foundation truly secure against static threats? Now that we've seen how deeply integrated an ESD floor is, and just how easily that protective network can be compromised by something as silly as the wrong cleaning mop or a drop in room humidity, well, it might be time to take a hard look at your own infrastructure. Take what we talked about today, look at your floor a little differently tomorrow morning, and just make sure your foundation is as secure as the server is sitting right on top of it. Thanks so much for hanging out with me today to explore this. Keep learning, keep questioning, and I'll catch you on the next explainer.